Okay, the first question, and this caused some confusion when people started looking at it on Friday. The idea behind this first question is to get you thinking about like terms. So we've got two families that are ordering piñatas, and we've kind of looked at just a small part of the candy in these piñatas. We're looking at the Snickers that are going into the piñatas, and we're looking at the Jolly Ranchers that are going into the piñatas. So we've got the Garcia family, and for the Garcia family, they wanted 5 Snickers. Let's make them green, Garcia green. They want 5 Snickers, and they want 4 Jolly Ranchers. The Thompson family, and I don't have a color that rhymes with T, or starts with T, so the Thompsons, will make them purple. They want 6 Snickers, and they want 1 Jolly Rancher. So when we look at the total amount being ordered, we need 11 Snickers and we need 5 Jolly Ranchers. And we know we cannot combine those any further. We're going to have 11 Snickers to fill these 2 orders, and we're going to have 5 Jolly Ranchers. And nobody would say, well, we're going to have 16 Snicker Ranchers or Jolly Snickers or anything like that. We would leave them as 11 Snickers and 5 Jolly Ranchers. That's a setup to get us ready for the rest of this idea, which is you only combine like terms. So we're going to see that now in number 2. In number 2, when we go to simplify, anytime you see simplify, think combine like terms. So when we are simplifying these, we are taking the x's. Let's go ahead right over here, make one of our t-charts. We've got x's, we've got 1's. We have 5 x's, and we have 8 1's, and we have 2 more x's, and we're taking away 7. So you could think of this as, you could go ahead and write it in here if you wanted to as minus 7. Some people find it easier to say, I'm going to think of that as plus negative 7, and it ends up looking the same way. So we've got 5 x's and 2 more x's, 7 x's. We have 8 1's and we're taking away 7, which would be 1. Or we have 8 1's and 7 negatives, which would be 1. Either way, we end up with 7x plus 1. It's always a plus sign here. This is always going to be a plus sign because we're thinking of the word and. So when you think of the word and, 7 x's and 1 more, when you think of when you think of and, think of plus. And plus are the same thing in math. All right, on to problem number 3. What's the value of 9 plus 3 times the difference of 5 and 3 minus 6? This is an order of operations problem. When we think of order of operations, some of you think of PEMDAS. You think we do the parentheses, then we do any exponents, then we either multiply or we divide, whichever comes first, then we add and subtract. Again, if you see the subtraction before the addition, you subtract. If you see the addition first, you add. So in this problem, 9 plus 3 times 5 minus 3 minus 6 more, the first thing that happens is right here. It's the parentheses, 5 minus 3. Nothing else changes that first time. We still have 9 plus 3 times the 2 minus the 6. The next thing that happens is the 3 times the 2. So now we've got 9 plus 6 minus 6. Then you can go ahead and do the 9 plus the 6. That's going to give you 15. Take away 6. And the very last thing you do would be the 15 take away 6, and you get the 9. And 9 is our final answer. Now you may have gotten the 9 by saying, well, I've got 6 minus 6 right here. So 9 plus 6 minus 6 is going to give me the 9. Either way, 9 is our answer for number 3. Now remember, as we go through these, if there are any of them that we discuss in the video and you listen to it and maybe you listen to it a second time and you still think, yeah, I'm not sure what that means, you're going to ask some questions. You're going to call me over. You're going to ask them at the end of the video, but you're not just going to sit there and think to yourself, I didn't understand it, but oh well. Okay, numbers 4 and 5 are going to be the same kinds of problems. And in both of these are both substitution problems. And by that I mean that the very first thing we do is we look at the problem and we say, all right, we have 5a plus 7b if a is 4 and b is 6. So that means we've got 5 times 4 because 5a means 5 times the value of a. So we have 5 times 4 plus, since b is 6, plus 7 times 6. 5 times 4 is 20. 7 times 6 is 42. 20 plus 42 is 62 is our answer for number 4. Number 5, we're going to do the very same thing. We're going to think of 6 times 4 minus 3 times negative 1. 6 times 4 is 24 minus 3 times negative 1 is negative 3. 24 take away negative 3 is just like 24 plus positive 3, and that gives us the answer of 27. Numbers 6 and 7 are sequence problems. So we're looking for the pattern, and they want the next 3 terms. So 3, 6, 9, 12. These are growing by 3 each time. Every time it goes up by 3. So 12 plus 3 is 15, plus 3 is 18, plus 3 is 21. So our next 3 terms are 15, 18, and 21. Number 7, what's the next term in the pattern? They're just looking for one more term. So these are going up by 0.2. 0.2 plus 0.2 to get 0.4, plus another 0.2 to get 0.6, plus another 0.2 to get 0.8. So we've got 0.8 plus another 0.2, and that's going to equal 1.0. If you wrote 1, you're great. Number 8. Which expression is equivalent to 4 times the sum of x and 10? So this was given to you if you wanted to think of having x plus 10 and another x plus 10 and another x plus 10 and another x plus 10. 4 x plus 10s. You could add them up. X plus x is 2x, and another x is 3x, and another x is 4x. 10, 20, 30, 40. 4x plus 40, letter A. You could also think of it as 4 times x plus 10, 4 times x, plus 4 times 10 would be 4x plus 40. All right, so remember again, if you've had any questions on the front, you're going to write some kind of note down to remind yourself to ask. To the back. Come on, to the back. There we go. All right, number 9. What is negative 2y plus 11 plus 2y minus 8 simplified? So we're going to think again of all of those terms. This time we have y's and we have 1's. So for the y's, we have a negative 2y. Then we have a plus 11 in the 1's. Then we have a 2y being added in. We're adding a 2y. And we're taking away an 8. Well, if we have a negative 2y and we're adding a 2y, those cancel out. Those create 2 zero pairs. And since we only have 2 and they create 2 zero pairs, they cancel out entirely. Over on the other side, we have 11 and we're taking away 8. Well, 11 take away 8 is 3. If you thought of this as plus negative 8, if you thought of having 11 and having a negative 8, then you could say, well, I've got 8 zero pairs. And 8 zero pairs meant that the 8 negatives canceled out 8 of the positives, leaving 3 positives. However you looked at it, the answer is 3. Okay, on to problem number 10. So in problem number 10, we're given this expression, and we're asked to factor it into this expression. And we're actually asked which of these fits this. So we can think of this from the standpoint of factoring the coefficient 4 and the constant 8. If we factor the coefficient 4, we get the factors of 1, 2, and 4. If we factor the constant, which is 8, we get 1, 2, 4, and 8. The greatest factor is the 4. And you can always, one thing you can always do first is look, does the small number evenly go into the big number? If it does, it's the biggest common factor. So that tells us that we are going to have 4 rows. So they gave us this original, but they're saying, what can we actually factor that into if we take it further? Well, here's what we can see is we're going to have 4 rows. So that leaves out B and C. And each row needs to have 4 x's, so 4 times x, and 8 1's, 4 times 2. So our correct answer is A. Now the way that we know that this is not complete yet, that this isn't done, is notice right now, each one of these has 2 x's plus 4 1's, but you can factor the 2 and the 4 further. We're not done yet. So that was telling us that whoever factored this and said, I'm going to make it 2x plus 4, I'm going to have 2. So that what this shows right here is 2 times 2x plus 4. They did not factor it far enough. It needs to be factored until there are no common factors inside the parentheses except the number 1. Number 11, add together 10x plus 2 and 9x minus 4. So we are back to the idea of having x's and having 1's. We've got 10 x's plus 2 1's. We have 9 more x's, so that was 10 x's, 9 more x's, and we're taking away 4. So I'm going to think of this as plus negative 4. I'm going to make that a negative 4. For my x's, everything's positive, so there are no 0 pairs over here. There are no 0 pairs. And I end up with 19 x's. That's the x part of my answer. For my ones, let's get a little bit rid of a little bit of that line there. For my ones, I've got 2 positives and 4 negatives. So that means there are 2 0 pairs. And when you add the 2 positives to the 4 negatives, you get -2. So our answer, we're going to have 2 possible answers here. We have the same answer written 2 possible ways. One way would be 19x plus -2, or you could have 19x minus +2. These mean these 2 answers are both the same amount. They're the same amount, just written slightly differently. Number 12, 8x plus 6 minus x minus 3. Here's one where I would definitely say you want to rewrite this as x plus -3. So you're thinking of 8x plus 6 minus x plus -3. And then how you proceed with it from here, there are a couple different ways to go. One way would be to say, I'm going to keep the 8x plus 6. I'm going to make this addition, and I'm going to do the opposite of everything inside. So here I had an x, which means now I have a -x. Here I was adding -3. Now I'm adding +3. If you do it that way, then you can do the x's and 1's, and you can say I've got 8x and 6 and a -x and 3. So my 8x and my -x makes 7x. There's 1 0 pair there. And my 6 and 3 make 9. 7x plus 9. A different way to think about it would be when you're back here, you could say, well, I've got 8x, take away an x. So I can break them into parts. Here are my x's. 8x minus an x. That's 7 x's. And I have 6, take away a -3, which is like having 6 plus 3. Subtracting a negative, like having 6 plus 3, which is my 9. Once again, I'd have 7x and a 9. Simplify the expression 8 times 3x plus 2 plus 3 times 2x plus 5. My daughter's dog's having a little fun out there. So in each of these, I want to break them into parts. And I want to do each of these. So 8 times 3x plus 2. I'm going to think of the rainbows. 8 times 3x plus 8 times 2. 8 times 3x is 24x plus 8 times 2 is 16. I'm just going to change the color on this last one because I know some of you put your screens on really dim, and then I don't want you to be able to not see it. That last little plus right there. Nice. All right, so that's my first one. Then I'm going to have my second one, which was 3 times 2x plus 5. So once again, I've got the rainbow. 3 times 2x is 6x plus, let's make this one red, plus 3 times 5 is 15. Now this was all addition, so I'm adding all of this together, which means I've got my 24x plus the 6x. There are 30 x's. And I have my 16 plus my 15, which is 31. And my final answer is 30x plus 31. Number 14. The area of a rectangular pool is 21x plus 12 square units. Factor 21x plus 12 to find possible dimensions of the pool. Draw a picture to support your answer. So let's start with the picture. This pool is a rectangular pool. They tell us that right there. It's not some fancy shape pool. It's a rectangle. And we have 21x plus 12. So really what this boils down to is if you have 21x plus 12, what do the factors end up being? Well, let's factor 21. Let's factor 12. 21 has as a factor 1, 3, 7, 21. Those are the only numbers that make up 21. 12 has as factors 1, 2, 3, 4, 6, and 12. Notice that the common factor, there's only one actually, is 3. So if we were factoring 21x plus 12, it would factor out to 3 times. And then we'd look at it and say, okay, this has to be the 21x. Here's the first part of the rectangular pool. This has to be the 12. 3 times what makes 21x? 7x. 3 times the 7. Remember we talked about how they work in pairs. And then the pairs for this are the 3 and the 4. So 3 times 4 makes 12. So we get 7x plus 4. And that is our factored form as the dimensions for the pool. This pool is 3 units wide, and it is 7x plus 4 long. So 7x plus 4 is how long it is, and 3 is how wide it is. And if you flipped those, if you said 3 was the long and 7x plus 4 was the wide, that's fine. Number 15, we've just got a couple factor problems here to finish up on. So, letter A, well, 6 factors to 1, 2, 3, and 6. 15 factors to 1, 3, 5, and 15. The common factor in those is 3, which means, let me move this over just a little bit, which means this is going to factor into 3 times 6x divided by 3 is 2x. There's the 3 and the 2 going together. Minus 3 times what makes 15? 5. And there's the 3 and the 5 going together. 7x plus 20. So let's factor 7 and 20. Well, the only factors of 7 are 1 and 7. It's a prime number. For 20, we have 1 times 20, 2 times 10, 4 times 5. So 5, 10, 20. Notice the only common factor is 1, which means that for B, the answer is cannot factor. It is already in, it's the only form it's going to take. It doesn't have a factored form. Finally, letter C, 8 and 28. So for 8, the factors are 1, 2, 4, and 8. For 28, they are 1, 2, so 1 times 28, 2 times 14, 4 times 7, the 14, the 28. The common factor is the 4, with the 2 there, with the 7 there. things keep popping up on the screen. So this is going to have 4 as the common factor. 8 divided by 4 is 2, plus 28x divided by 4 is 7x. That's where the 2 with the 4 and the 7 with the 4 popped up. So this will be 4 times 2 plus 7x. This was cannot factor. And this last one, or the first one actually, was 3 times 2x minus 5. Okay, here's the great thing about this being on a video. You can watch it again. You can slow it down. Well, actually, it doesn't make sense. You don't want to listen to my voice in slow motion. You can watch it again. You can replay it. You can use it to help you figure out what you need to make notes on tonight, so you have notes for tomorrow's test. Please be sure you ask some questions if there are things you don't understand, and go back through your homework. Use those types of resources to make up some questions for the test. All right, come in tomorrow prepared to be successful.